Good morning, everyone, and welcome to today's webinar on Socially Driven HVAC Optimization. We'll get started shortly, but before we do so, I'm Andrea Silvestri, and I'll be walking through a few webinar logistics. Today's webinar is based on a report by Oak Ridge National Laboratory, and you can find the full report as well as two summary documents that synthesize the results, a 4-page findings and a 1-page infographic at gsa.gov. It's also a webinar that's one in a series. It's our 8th webinar, and the next webinar in January we'll be hosting a webinar on 2 next-generation chillers, the variable speed magnetic bearing chiller and the variable speed direct drive screw chiller. And a recent report assessed both chillers at the Yates Federal Building in Washington, D.C., and it's now available at gsa.gov as well. In February, we'll hold a webinar on advanced power strips and plug load control, and this will talk about our report that was released in 2012 as well as more recent research in the field. In March, our webinar will feature the Honeycomb Solar Thermal Collector, and this collector is particularly effective for solar hot water systems that don't have a storage tank. April's webinar will discuss electrochromic windows. GPG has just released 2 reports by Lawrence Berkeley National Laboratory, and those are also available at on gsa.gov/GPG. Another thing to note is that all the past webinar recordings, as well as the recording for this webinar, will be available, and they're posted on the website. GPG webinars offer 1 continuing education learning unit through the American Institute of Architects. To receive credit, you can complete the post-webinar survey. If you don't receive the survey, you can reach out directly to Michael Hobson. During the webinar, we have all participants, your lines are muted, but you can answer and ask questions here at the right side of your window in the chat window, and you don't need to wait to the end of the presentation to do so. In fact, we encourage you to submit questions well in advance of the Q&A. And now let's get started. Mike Lowell will be facilitating today's presentation. Mike.
Thank you, Andrea. Welcome, everyone. And Andrea, next slide. As the slide said, I'm Mike Lowell. I'm a project manager with the GSA Proving Ground program. You can see now on the screen the agenda. The agenda here, hoping if he makes it, we'll have Kevin Powell, the director of the program, give an overview of GPG. If he does not make it in time, I will give that presentation. After that, we'll have Dan Howitt from Oak Ridge National Laboratory, who is the principal investigator for this study, present his findings for the testing of this technology. After that, we'll have Gabriel Sanchez and Mark Levi, both people in the field that have utilized this technology, and we're also in the region where the test was located, give us on-the-ground feedback. And lastly, we'll have a Q&A session that will last about 15 minutes where you can provide your questions in the chat, and we will go through those questions and respond to those questions at the end of the presentation. Next slide. And Andrea, I didn't look. Has Kevin made it, or is it up to me?
I think, Kevin, you're with us. Can we hear it? But we don't hear you. So Kevin, send me a chat. We're not hearing anything right now.
Oh, hello?
Okay. Yes, we can hear you now.
Okay, there we go. All right, well, hello, everybody. I want to, again, just say thanks for joining this webinar. Next slide. Okay. So just a few quick words. I am, of course, the director of the Emerging Technology Program at GSA. This program has a couple of different tracks. One, the Proving Ground program, which takes in next generation technologies, evaluates them in the real world context of our buildings. That's what we're largely presenting today. And then we also have a pilot to portfolio program. This enables us to really leverage what we learned from those technology evaluations and deploy the most effective technologies across our portfolio. Next slide. Just, a key sort of premise of the program, and again, I think you'll see that in the case of this particular technology that we're going to talk about. There's a really rich pipeline of innovation on the R&D side, and there's some really cool things that came out of UC Berkeley that really are the underpinnings for this technology that we're going to talk about. But getting that technology into full commercial maturity where it's got market acceptance and it's got full-fledged market pricing, that is the challenge. And of course, the other challenge is that when we have facilities, there's a fair amount of, they're risk adverse is basically the bottom line. So GPG helps bridge that gap, establishing confidence that these technologies work in the real world of our operating buildings. And as you can see here, to date, we've deployed 9 of those technologies that have proved out, and it's really some rather significant, savings. Well, that's not good. Okay, next slide. Audio majorly cutting out. Well, let me talk super quickly since my audio is terrible, and I don't know how to fix that. But basically, you can see on the we'll just actually say that it's a rigorous process to be accepted into the GPG program. Next slide. And with that, we'll bring our colleague Dan Howitt onto the presentation.
Good morning, good afternoon, everybody, depending on which time zone you're in. Hello?
We hear you.
Okay, good.
Yep.
My name is Dan Howitt. I was the principal investigator on this project. And this was a very interesting project. Next slide, please, Andrea. This project, or this technology, this socially driven HVAC optimization, was selected in 2013 for the GSA Proving Ground program. Throughout this talk, I'll toss out the term comfy when referring to this technology. It was one of the trade names or nicknames given to the technology. It's just a whole lot easier to say than socially driven HVAC optimization. The vendor for this company is called Building Robotics. They are based in Oakland, California. At the time when they entered the Proving Ground program, they were 3 individuals, the founders. They've now grown to 60-plus employees in 2 different cities. This evaluation was conducted in 2014 at the Federal Bankruptcy Courthouse in Phoenix, Arizona. And as a note, I've been working with the GSA Proving Ground program since the beginning. And I have to say that this is the technology that has taken me from the greatest state of skepticism to proving that it actually worked. I once called the technology a, quote, video game thermostat at the kickoff meeting, but then I felt really bad because Andrew, Stephen, and Lindsay were sitting right there. But at the end of the day, I have to go where data leads, and their brainchild really did work as promised. Next slide, please. To understand how comfy works, I think it's important to talk about how current space temperature control happens. Basically, buildings are set, or spaces are set, to operate within a deadband. If they get too hot, they get cooled down. If they get too cold, they get heated up, but the temperature bounces around or fluctuates between a high point and a low point. And there's occupied, unoccupied schedules. Maybe there's an occupancy sensor. But still, there's 2 numeric temperatures involved. Next slide, please. Current temperature management from an occupant's perspective kind of follows these 4 steps. If there are still thermostats on the wall, if the occupant's too hot or too cold, they can get up, they can adjust the thermostat. until that gets readjusted by another coworker or a building staff. Most thermostats on the walls are not accessible by an occupant. In that case, the occupant, if they're too hot or too cold, they have to enter a work order. They wait for the building staff. They wait until a lot of times step number 3 comes involved. If they can, the occupant opens up a window, or they buy an electric heater, or they put on a sweater. The staff wonders about energy usage. The occupants get grumpy. And heaven forbid that there be a cube farm where the debate has to happen. Option 1 or 2 is used to try to get the space temperature selected. And the loser of the debate, they open the window or they buy the heater. Next slide, please. Here is how Comfy is different. And I don't want to leave this slide until folks really understand it. Comfy works from the premise that if occupants have a direct and immediate control of their space conditions, that they will be more comfortable under a wider range of conditions. Their bodies will be comfortable if it's a little bit hotter or a little bit colder. The way this premise gets implemented is that the occupants, they use either a desktop app or an app on their mobile device. And if they are too hot or they are too cold, they can send a message of too hot or too cold into the app, and they will receive within their space an immediate 10-minute stream of warm or cool air to address their condition. Now, when we were commissioning this system out in the Phoenix courthouse, we walked around to the different spaces with the technology vendor. They would enter the too hot or too cold message with their mobile app, and truly immediately, within 10 seconds, we could hear and feel. We had to listen closely, but we could hear the VAV boxes opening to full open and applying. Andrea, it just says my screen is saying the connection is lost. Can you still hear me?
Yes, we can still hear you.
And
Okay.
I still see the screen.
Okay. I've got a hard copy here. We'll just wing it. Not sure what happened, probably on my end. Anyways, as we were commissioning the system, the vendors would put in the too hot or too cold signal. Within 10 to 20 seconds, we would detect the pulse of the cool air coming out of the VAV boxes that went full open, and that would last for 10 minutes. In the background, and this is what the key part of Comfy, is while the occupants are giving feedback of too hot or too cold and getting their immediate needs met with these bursts of air, the technology is constantly adjusting the temperature to save energy, adjusting it to different set points. That is the core of what Comfy does. Next slide, please. Should say how it works on the top.
Yes, that's where we are.
Okay, thank you. This is just a graphic that comes from the Comfy advertising literature. It really communicates the point that the occupants have this mobile app. They are sending a signal directly to the BMS that directly impacts the VAV boxes serving the area. There are no work orders involved. There's not even a getting up and walking to the wall to adjust a thermostat. Next slide, please. As I said, this test was conducted at the U.S. Bankruptcy Courthouse in Phoenix, Arizona. It is important to note that during the test, we not only tracked conventional metrics such as temperatures, the number of too hot or too cold work orders, or the maintenance required on the building staff, we also engaged the lab anthropologist to measure how the occupants reacted to the technology. Her area of expertise is human-machine interaction. The final report was 82 pages long, which is about triple what a normal proving ground report is, but about 2/3 of that report were findings that came from the human side. of the project. Next slide, please. The test plan and a snapshot of the result. This graph looks somewhat crowded, but it shows the space temperature from a representative space during the time span when the comfy system went active. We have been documenting baseline temperatures, comfy went active, and 2 to 3 weeks later, we noticed that the temperature in that space had shifted about 2 degrees on average to a more energy-saving point. This is the data that started me thinking, yes, this video game thermostat really did work. Now, of course, the skeptic in me is thinking, okay, fine, the space is now at a warmer average temperature. I know we are saving energy, but are the occupants still comfortable and happy? Next slide, please. This is some of the survey data, and we took quite extensive surveys and interviews of people and of occupants. The bottom line is that the people within this facility, the occupants, not only were they more comfortable when the comfy system was active, they also found it a very easy system to use. There were very, very few complaints with, you know, gee, this is awkward, this is hard, et cetera, et cetera, et cetera. Gabriel Sanchez, he will talk more about this because he was the frontline person actually interacting with people. And I see it on the questions, one question about how does this work in a cubicle space. What it does is it actually surveys occupants and it makes selections based on, it's a voting device. And again, Gabriel, more information on that. Slide, please. As I said earlier, one of the things we tracked was maintenance requirements. Of course, we were tracking number of cold calls and number of hot calls. And these are not the calls where somebody typed in the app, I'm too hot or too cold. These are the times when somebody actually requested a work order that a maintenance person had to come out and respond to a situation, actually check on a hardware condition or something like that. The number of work orders requested dropped by over half once the technology was installed. Next slide, please. We wanted to assess what would be the overall impact of this technology. Would it be economically viable based upon energy savings? So what we did is we did some energy modeling. We used the standard models that were developed by PNNL for small, medium, and large office buildings. We looked at them in, I think it was a total of 15 different cities in the different climate zones. And we started from the premise of, okay, since we had witnessed a 2-degree change in temperature set point, if the deadband would expand by 2 degrees in both the heating side and the cooling side, how much energy potentially could be saved? And what we found was, on average, about 20% cooling energy savings across the board. Next slide, please. As I said, we looked at a lot of different cities, a lot of different utility rates, climate zones, things like that. One important note, these energy savings that we modeled, and we have up here on this slide, they do not include O&M savings. They do not include energy savings that may come from the reduction of personal fans and heaters and open windows. It also does not attempt to document any increased productivity that may result from increased thermal comfort. That is one item that the vendor purported as a benefit of their technology. It's extremely hard to measure and document that particular item, so we took it out of the project as far as something that we wanted to measure. Now, we need to note here that at the time, the company, Building Robotics, they were still new. They were, quite honestly, still working to figure out their pricing structure. Based purely on energy savings and energy cost savings at the time, this technology was not economically viable. It was saving energy, but not in a way that was cost effective. However, there were a lot of other benefits that the building experienced, and Gabriel will talk more about it during his portion. Next slide, please.
Hi everyone, my name is Gabriel Sanchez. I'm currently the Smart Buildings Program Manager for Region 6. However, at the time this technology was being tested, I was out and part of Region 9 and was definitely heavily involved with this technology, so I wanted to share some of my experiences with the use of this technology. Next slide. So one of the biggest hurdles that we found basically with the use of this technology was getting the tenants signed into the correct location. Many of the tenants, they know that they would come to the office building, they know they got off on the 7th floor, they know that they went to a particular room in the area, but many of them didn't know, exactly what VAV controlled their space. So it was kind of a little bit of a logistics that we had to work out to get people signed on into the correct area. But once they were signed up, users could access the application either from the web interface on a website or typically using an app on their phone. It was an app that was downloaded, then they would sign in, indicate what area they belong to, and then they were pretty much into the system. And that was a question that was brought up, but yes, so there was a particular app that was available for both the Apple interface and the Google interface as well. Next slide. So the technology itself offered two different control modes, and we got to test both of them. The one I'm going to talk about first is the standard mode. Essentially, this is a pre-programmed offset that gets put into the system, and the set point will never adjust itself from there, barring the feedback that, with the exception of the feedback that's coming in from the user interface. So if the 2-degree swing jumped up, we'll just take a starting point of 76 degrees there. It will not actually adjust itself from there periodically throughout the day until the user would implement some sort of command indicating whether or not they were too hot or too cold. In Phoenix, for the most part, it is a warmer climate, so for the most part, a lot of it was cooling requests. However, it's still a desert. It does get cold, so there was heating commands that could come in during the winter as well. So the standard mode never actually deviated from that top set point. It would just adjust itself for when users would provide that feedback. Now the other mode, which is learning mode, is actually kind of a neat function. We tested this, for a long period of time, and it actually offered, quite a great response, overall. Throughout the day, people would indicate whether or not they are too cold and too hot. And the system in learning mode will actually record this information and will adjust itself as it notices trends. So for the next few days, if it notices around, say, 11 o'clock, everybody's saying that they're too hot, then it's going to automatically adjust itself down to automatically accommodate for that 11 o'clock time. The downside to that was if people would go on vacations, there would be no requests coming in, the system would automatically start adjusting itself back up. There wasn't a way to kind of put it in vacation mode to accommodate for that, or maybe long holidays for the entire facility. So the learning mode had its advantages and a couple of disadvantages. And the technology itself adjusts a set point in the background. You can manually adjust the upper and lower ends. So in other words, next slide. So in other words, we would get data from the users, which would tell us how many requests were coming in per particular zone. And with that, if we noticed that there were some areas that had a lot of requests, then it would kind of give us a profile to adjust the temperature a little bit differently in that area. Areas that were not getting a lot of requests, it also provided us the data, say for example, if no requests came in, it would let us know that this area, we could probably warm it up another ½ a degree. So we would actually make some adjustments to squeeze out some additional energy savings doing that. We also had a couple users that were, maybe thought the system was a video game and would sit there and press it all day, every minute, every second. And so we got that end of it, and the system still only took into account one click for every 10 minutes. So if the user particularly said that they were cold, regardless of the amount of times they hit that they were too cold for the first 10 minutes, it would still only record the first one, and it would have to wait till the next cycle before it would pick up an additional click. So there was no way to kind of trick the system into remaining into a cooler state. It had to consistently being, told that it was, too hot or too cold in particular. And in the learning mode, it would start to adjust for that, and we would see areas kind of taper off in learning mode. So while one area this week had an excessive amount of clicks, once the system learned that particular pattern, the following week we'd notice a decrease in the amount of clicks as well. So in learning mode, it definitely offered an advantage. The data provided us with a lot of different information as well. So in one particular instance, with the amount of clicks that were coming in indicating that the space was too cold, space was too cold, space was too cold during the heating season, we ended up going in, physically verifying to find out that we had a thermostat that was reading far beyond the normal range that we can adjust it. So in that particular case, it let us know that there was a thermostat broken. So it's kind of a third-party auditor, per se, letting us know how the space is actually doing, which would prompt an actual service call that we can utilize to dig into it a little bit further and investigate. Next slide. Bottom line is we kind of eliminated a lot of false hot and cold calls. There was a lot of occupants that would be reporting whether or not they were too hot or too cold. And in the instance where it's covering a large area, for example, that there are, say it's a group setting, and we have an open office space location, maybe 6 people are sitting in there, or however many it might be for that particular zone. If one person indicated that they were too hot or too cold, the system was smart enough to know to poll the other users, the other 5 users in this instance, to ask them whether or not they are too hot or too cold as well. So in that particular instance, one person initiated the too cold call, we'll say for this example, and the other users would indicate, I'm comfortable. So you had the option of too hot, too cold, or I'm comfortable. If they indicated they were comfortable and the other 5 users indicated the same way, the system would not actually accept that too cold request, and the system would remain in the same state. So we always have that location that has certain users that are always too cold, always too hot, and this kind of helped mitigate that without anybody else dipping in. Normally, we get a call, it's because one user in that particular area, and I know as a former technician, I would kind of ask the other users, hey, is it too hot in here? We got a call. And there'd be times where I get feedback of saying, no, it feels great in here. So the system kind of handled that by itself, and there was no other people that needed to get involved with that. So that was definitely a benefit with the use of this technology during that period. Next slide. So in addition to some of the energy savings that did appear from the use of this technology, there started to appear some ancillary benefits that came out of the use of this technology. And one in particular was the increase in our tenant satisfaction scores over the average thermal comfort in their particular area. So we just wanted to throw some data out there just to kind of give everybody an idea of kind of how it worked. But prior to the installation of the technology, we had a tenant satisfaction score of 3.2 related to tenant satisfaction. And after the technology was put in place, we climbed all the way up to 4.3. I can tell you from personal experience, talking with the tenants, they were happy, they were great. They had control over their space. It may have been a temporary relief of cool air or a temporary warm-up, but that gave them the benefit of feeling comfortable and giving them the ability to adjust the temperature in their particular space. And once the technology was removed, we can see that the tenant satisfaction scores actually dropped to the point to where they were worse off than we were in the beginning, probably because we gave them a taste of something great and they didn't like it once it was removed. However, the reasoning being it was definitely an improvement. So in our particular case, there's definitely an added benefit to the additional costs associated on top of the energy savings in the fact that, we're doing, providing great benefit to our tenants. I can say from my personal experience as an actual technician from the field, our primary purpose for an HVAC system is really tenant comfort. It's also there for cooling down, additional spaces like data centers and stuff like that, but really the primary purpose is for tenant comfort. This offers the ability to not only save some energy, but provide that level of tenant comfort that we need to focus on as it relates to the HVAC system. So this provided ancillary benefits on a couple different levels. Next slide. So as far as cost effectiveness, I know I touched bases on that. Within the federal government, we occupy our buildings for approximately 10 hours a day, 5 days a week, whereas facilities that operate, per se, on a 24/7 operation, they're going to get more of a benefit from this financially because of the additional energy savings involved with the added hours of operation. For the federal government, we didn't get to see those additional cost savings benefits, but there was definitely a cost savings benefit on the energy savings just with the use of this technology. On top of that, we definitely had a reduction in hot and cold calls. Essentially, we cut those a little over half. And however, because of O&M contracts and the pricing being fixed, we didn't actually see financial benefit from that. However, there was definitely, a reduction in costs as it relates to, hot and cold calls and our contractors coming in to take a look at that. And then some of the things that we did find out with our tenants as well is some of the tenant agreements that we did have in place kind of limited our ability to change some of those set points. So we couldn't take advantage of the full 2-degree additional deadband that we would be able to in other areas. So that was something to take into consideration as well. Next slide. An additional benefit that we found, which was definitely a tenant preference here, is the technology was really geared towards our tenants. And when you talk to them and you hear the feedback from them, it was great. I know I mentioned that before, but honestly, that was a huge benefit that we got, when we would talk to our tenants. Everybody enjoyed the technology. They liked having that additional ability, and we showed that in our tenant satisfaction scores. We can't put an energy savings, dollar attached to that. However, it's definitely a benefit and definitely a value in terms of some additional costs we'd spend towards achieving that marker as well. And one additional benefit is because of all the data that we were receiving from this particular system, we were able to kind of develop an entire building profile that was geared towards the tenant. So normally we try and build our HVAC profiles around typical cooling temperature set points and whatnot, but we were building profiles based on the actual tenants and their personal preferences, and that added a lot of valuable feedback as well. Next slide.
And Mark, Levi, you're going to talk a little bit about your experience with trying to get the technology into the Pacific Rim, into Region 9.
Okay, sure. You can go ahead and
Thank you.
go to the first slide if you want. So my part of this is pretty brief. This will take me a couple minutes. I was basically given the assignment of, after all the positive things were said, to throw the wet towel at the end. Following the test project in Phoenix, we sort of tried to do two things. One was to extend use of the system at Phoenix, and the other was to do a second comfy installation, which would be part of an ESPC. It was actually a phased ESPC, so we were negotiating the second phase. And we ran into two problems. One was that for the ESPC in particular, the cost of the system was rather high. Instead of buying use of the software and the application, and then basically having it and amortizing off the cost over the years, Comfy, at least at that time, I'm not sure the current model, but at least at that time, was working on a per square foot per year licensing model. So you'd have to pay by the number of square feet over which you were using the system. at a certain cost and pay that every year. And that simply was very expensive, especially with a large building. It tended to add up to be quite a bit. There wasn't any real economy of scale built into the pricing model at the time, if I recall. Now that was coupled with a second problem, which was being a combination of a new technology combined with it being driven really by occupant conduct as opposed to something that's easier to calculate. It wasn't really financeable as a guaranteed savings. So we could do estimated savings. We could say it looks like it's going to save, but we couldn't guarantee the savings within the ESPC. And with ESPCs, you sort of need guaranteed savings because that's what lets you fund it with a loan. Now, on a small, on a modest scale, we could sort of bury it with a lot of other stuff and not have the guarantee. So that didn't absolutely stop us. It probably would have prohibited us from doing it on a really large scale, but we could have put it in as at least a measure for some floors of a building. What actually killed us completely was IT security. GSA takes IT security, very seriously, which is a good thing, basically. But it can be rather onerous especially for a smaller company or a startup. To get the system cleared, they would have had to have, first of all, had the hardware device scanned and remediated. Basically, central office runs it through a scanning process, finds vulnerabilities, as well as reviewing all the product literature. And then they have to work off the vulnerabilities and have the device rescanned and so forth. It's a process that typically takes around 6 months to do, and a certain amount of time on the part of the contractor. Secondly, the software application would also have to go through a similar process and get approved. That takes more time also because often there's findings that require reprogramming. And then the third issue in this particular case is that the GSA sort of secures its building automation stuff within a secure VLAN. It's basically walled off from the rest of the GSA network. So you can't actually get at most of the BAS systems from the outside except through certain very narrowly defined methods in which you have to have a GSA IT account. But here, because all these personnel from other agencies have to be able to access the system, it's treated as publicly facing. It's sort of like treated as an automation system that's supposed to be in this secure network, but actually has to face the public. And that creates a whole bunch more security issues. It's certainly not impossible to do. It is done, but that has to be tested and be brought into compliance, and that can be fairly onerous. So essentially, there was a fairly onerous process that they had to go through, and Comfrey just declined to do it. They basically said they couldn't cope with it and pulled out. So the first problem we could have gotten around to some extent, but the second problem we simply couldn't. And as far as I know, that's where things still remain today. I mean, Comfrey has not, or Building Robotics has not agreed to go through the GSA IT security process. And in their defense, I should point out that while the IT security is a good and necessary thing, the federal government is a little bit inefficient in how it does it, in that every agency is doing this on their own and has totally different ways of doing it. So if a company goes through all this with GSA, it doesn't help them a bit with Veterans Administration or Defense Department or anything else. It's just, it only gets them into GSA. And then plus, every 3 years you have to do some degree of doing it all over again. So it's a fairly onerous process and difficult for smaller companies to really handle, especially when they have to do it on an agency-by-agency basis. So as far as I know, because of this, unless Building Robotics changes their mind and is willing to go through that process, the system simply cannot be used in GSA, as of today. Andrea, I think that's all I had.
Thanks, Mark. And with that, we'll turn it over to Q&A. I know we have a number of questions, and Mike, thanks for facilitating those.
Okay, thanks, Andrea. First question is from Richard. Is there any work being directed to the optimization of refrigeration and freezer units as contrasted from air conditioning by GSA? Kevin, I don't know. I'm trying to think off the top of my head. I can't think of anything. Are you aware of anything?
I am not aware of anything at all, no, is the answer.
Okay.
Yeah, this is Dan Howard at Oak Ridge. We have a group that's looking at refrigerator and freezer stuff if you'd like to contact me offline.
Thanks, Dan. Next, we've got Kovas, who asks, what happens after 10 minutes of temperature adjustment? And the answer is temperature set point would resume where it was prior to the temporary adjustment. Jeff Truex asks, how would this fit with cybersecurity, having an app that accesses the BAS on the GSA network? And as Mark shared, it's kind of an onerous, well, we see it as a vulnerability. And at this time, it is a vulnerability that hasn't been addressed. So I think Mark did a pretty good job of sharing with you where that puts the issue.
Yeah, one thing I should mention, but I should mention, is that for the test project in Phoenix, essentially IT granted they sort of waived the normal requirements. So this was put in without any of the normal security stuff being done, but we couldn't either keep the system going or do it anyplace else without running it through the normal security procedures.
Great, thanks. Jose asked, good for private, but what about open area? And as Dan indicated, this is in, we use in open areas, and it kind of takes a holistic approach, kind of taking votes from those people in the cooling or heating zone. Tino asked, is a telephone app and also desktop? And yes, it can be used for telephone, laptop, and desktop. Jason asked, would you need building Wi-Fi? And the answer is no. It's used with cellular service or in the case of laptop or desktop, of course, whatever network is in place in the building. Tino asked, will this be available for customers and personal devices or GSA-approved devices? And it's a question hard to answer. Currently within GSA, because of the IT issues, we don't plan to deploy it in the near term in GSA. In the case of other federal agencies, likely the applicant, in this case, building robotics, would have to go through an IT security process. So frankly, that's a question probably to be answered later. April asked, would this be something better suited for new construction or to implement in existing systems? And we found that actually it'd be great for either scenario. Of course, it would also be project dependent, and it would probably vary from project to project, but we see it as a deployment possibility aside from the IT issues for either type of project. Jonathan asks, I'm not following this question. Let's move on, and maybe someone, Carolyn, you can put something there, but I'm going to move into Tina's question here. And can this be breached, or does GSA IT have any concerns about security? And as we've said before, IT security is a major concern for this technology. John Carson asked, probably missed this being discussed during that slide, but what was the basis for determining which cities would best be suited to this technology? Dan, I might just ask you to maybe talk a little bit about your modeling.
I don't know that was the question about modeling, or was the question focused on how did we select Phoenix? The reason we landed at the Phoenix, we went through the usual selection process. When we try to find a demonstration site, we worked with the vendor. What sort of to find what would make a good site. The facility had to have a VAV system, which the Phoenix facility had. It had to have a site staff that was eager and receptive. I don't remember all the criteria, but that's how we chose Phoenix. As to how we chose the cities, those were just representative large cities within each of the climate zones. We went for a variety of climates, a variety of utility rates. We took the building models, and we just wanted a representative picture.
Thanks, Dan. John asks, Gary asks, is there some placebo effect with this? And our answer was there was a difference in requests as we toggled through standard and learning mode. In learning mode, as the temperature was adjusted, the amount of requests decreased. This helped to address the placebo effect. Dan, I don't know if you want to say anything more about that.
Yeah, I appreciate that, Mike. I saw that question when it came up. Dr. Wolf, our anthropologist, was actually quite concerned about the placebo effect. Basically, if we give people this device, would they be comfortable even if the temperature never changed or anything like that, which is a documented effect of, that can happen sometimes. What we concluded, though, as we were going forward with this is, this device, when you give it to somebody and you use it, number one, like Gabriel said, there was a lot more occupant satisfaction, and that's really where the placebo effect, would appear most. But because we were also tracking temperatures, we documented that the temperatures changed too. By documenting that the temperatures were changing, we know that energy was being saved. So, yes, we thought about it, but at the end of the day, the issues that we documented, were occupants happy? Was energy being saved? We had to go where the data led us. It was yes on both accounts.
Thanks, Dan. Ron asks, how large are the zones in the AHUs? In this particular building, there were several side zones that were tested, anywhere from a single office to large open space, open office spaces. Don't have an exact number of occupants, but it varied greatly within the test area. Tino asks, you stated if one click per 10 minutes, is that the number to be adjusted lower or higher? In cooling, it would adjust the temperature for 10 minutes to supply a burst of cool air. In heating, it would do the same to supply warm air. In areas that only offered cooling only, heating requests would turn off all airflow for a period of 10 minutes to allow space to naturally warm up. Next question, Michael Kroll asks, do users log in or just enter the space they are sitting? They do log in and program the area they work in. Once they log in, their space is already programmed. If they move locations permanently, they will need to contact the company to have their location tested. Gabriel, I saw a slide in your presentation that spoke to this. Is there anything you'd like to add?
And we also have Lindsay Baker on from Comfy. And Lindsay, I don't know if you'd like to talk about this as well.
That sounds about right to me, actually.
Okay,
I don't know if
great.
there were further questions, but I can get into more detail if people would like.
One question, and Mike, we might get this to, at the end. There have been a lot of questions about IT security. Maybe
I was going to let her maybe address that now,
okay,
since she's
great.
on. Has anything changed since the study, Lindsay? Your thinking,
Sure.
your policy, your pricing? I'm going to go for the whole shebang.
Yeah, maybe I'll just say certainly the pricing has evolved a little bit, especially for larger buildings. We've managed to get our costs down, so that allows us to get the price down as well of deploying to larger buildings, which I think makes it more scalable. The cybersecurity question is absolutely still one of our challenges, and I have to say I think it's a sort of a partnership question between us and our clients that we have to evaluate every time we go into a new client arrangement, which is really just that different clients have different types of requirements for cybersecurity. So we work with a lot of large tech companies, Google, Salesforce, Microsoft, those kinds of companies. And we have managed to get through their cybersecurity reviews. We have done a number of cybersecurity certifications in the past couple of years, and that I think have helped us really be set up. You can actually see on our website we have a trust center now that details some of those improvements. But it is still a very onerous process. The federal government approval process is probably a lot more significant than those. Which is, interesting, and I think to me, I will say it's not always a question of how rigorous the review is. It's the bureaucracies are quite different. So we have managed to get through, I think, some pretty rigorous reviews of cybersecurity for different types of companies. Banks as well, I will say, we've gotten through. We have a couple of banks that are clients of ours, but the federal government one looked a little bit too time-consuming for our still relatively small team to get through.
Thanks, Lindsay. Gary asks, has this technology been explored for IAQ? And it was not in this test case. Additional parameters that need to be fed into the SIP to accommodate a complete IAQ approach. Lindsay, I don't know if you've explored that or been asked that by others.
I will certainly say that it's one of my passions and one of the reasons we started the company, to add layers of information about buildings and allow occupants to use that information to choose where they locate and to operate the building better. So things like, understanding CO2 and gathering CO2 data from sensors in the space, or particulate matter, or those kinds of things, are aspirations of ours over time. We would love to have that data plug into the interface just to complete that picture. Acoustics as well, I'll mention, and lighting. These are all areas where we see an opportunity for gathering that information, having it collected and used to help people choose. I won't go into all the details of how all that would work, but it's certainly on our long-term vision.
Great, thanks. And then Chris asked, did you consider using the data to group all the hot call people and cold call people together? And this was discussed but not explored further. There was a lot of valuable data being provided as part of the system, but again, it was discussed but not pursued. Richard asked...
I'd like to add a little bit to that, if you don't mind.
Sure.
So one of the things that I valued the most about this system, especially our partnership with Building Robotics at the time, was the amount of data that they were providing us. It was just phenomenal data. You want to say at times that it was kind of overwhelming, but the amount of information that they were provide in terms of this entire process was just amazing. It allowed us to look and approach how we do HVAC control to tenants on a whole new level. And for that, I just want to praise Building Robotics on what they did and to be able to give that data.
Thanks for that. That's much appreciated. And I will say also we do have clients who do use that data to place people in spaces that they might find comfortable. And for those of you that don't have comfy, I will just say anecdotally, a lot of what we find is that people who run colder, who like it to be a little warmer, put them on the south side of the building if you can. Obviously, that's not always a choice, but vice versa for people who run hot, or maybe they wear three-piece suits or something along those lines. The north side of the building is always a better option, and certainly the east as well.
Thanks. Richard asked, the person nearest to the vent might overreact as compared to others more remote from the vent. Was that considered? This was. The system allowed for us to consider mechanical changes as needed. The thermostat was just one example. Gabriel, I don't know if you want to speak more to that as well.
Yeah, there was a lot of considerations that we made depending on how the system actually reacted. And I know I kind of touched bases on one of the previous questions, but so in that particular facility, our exterior space, our exterior zones, they actually had heat built into the boxes, and while our interior zones did not. So it offered a different perspective. So when they would indicate that they were too cold during the heating season, the box itself would actually just shut off. So the airflow would temporarily shut off, and we'd have to rely basically on the natural heat generation of the computers or personnel in that area to warm up the space. When that didn't work, and there was too much going on in order to try and heat the space, that's when we took into consideration, should we be moving how we treat the mechanical space. And so the interior spaces, we changed minimum airflows, we made some additional changes. In one particular case, we actually shut a vent off for that particular area because the tenant was just simply too cold. Regardless, even in the zero mode, we just couldn't get that space to warm up. So the system itself gave us a whole new perspective, like I indicated before, and we kind of tackled each issue, as they came up. And whereas if you have a vent that's directly blowing on somebody, say, it's too hot in the area and they want to cool the space down, you kind of have to also rely on your tenants to self-monitor themselves. So in an open office space type of location, I believe they changed the seating on a couple of people to kind of accommodate that as well.
Great. Thanks, Gabriel. We're running short on time, so I'm going to zip through the rest of the questions. Did the O&M see this as a benefit or burden? Both. In the beginning, it was a burden, but as the system started to take over, they saw the benefits. Jack asked, 20% savings seemed very high. Normal rule of thumb is 2 degrees, would save 6%. Is 20% real? You are correct that 2 degrees is an average of 6% for a 24-hour period. However, the 20% was total savings. Jim asked, do you think there is any other way to save money? Someone answered meeting rooms. This is now in use on current revisions of the software. David asked, on the cooling side, what is the delta between high and low set points? Depending on the zone, it varied from 4 to 6 degrees. Rebecca Olson asked, would the same IT issues persist in a lease location? I don't know if we ever, good question. I don't know the answer to that. Anyone else?
I could probably answer that. If it's if the application is being hosted by the lessor, not by the government, then no, they would not. It will be purely just operating the space as a privately owned space.
Right. Thanks. Paul asked, admitting his expenses, can you offer actual cost per person per square foot? Dan, I don't know if we did any kind of computation like that.
Yeah, this is Dan. We did not break it down on a per person per square foot basis.
Okay, thanks. Jason asked, would there be any benefit to merge this technology with NCMMS? It can possibly be incorporated into SkySpark, which is the platform we use, with the use of custom rules. Great option to explore. Michael asks, if the space is associated with a user's account, can they use it in a conference room or non-permanent spaces? Gabriel, Mike, Mark, Dan, any thoughts on that?
So that was something that, early on in the early adoption of this technology, I know we spoke to Building Robotics to see if that was an option. And I believe your current revisions of the software now have that capability. Is that correct, Lindsay?
Yes, that's correct.
Great, thanks. That's it for the questions. Thank you, everyone, for both attending and the questions. I'm going to turn it back over to Andrea.
Thanks, Mike. So we want everyone to know that a copy of the slides as well as a copy of this presentation will be posted shortly on gsa.gov/GPG. And to also remind you that right after this webinar, you will be receiving an email with a very short 5-question post-webinar survey. If you complete that, you can receive continuing education credit. If you don't receive the email, please reach out to Michael Hobson. And thanks again to everyone for being here, for participating in the webinar, and for the presenters. Hope to see you next month. Thank you. Bye.